Hey guys, this is the second last section of this unit, and it's called the triangle proportionality theorem. That's basically what this whole section's on. So another name for the triangle proportionality theorem is called the side splitter theorem, and you can kind of see why in a second. So what it says is if we have a line that is parallel from one side of the triangle, so this little triangle, let me read that again. So if a line is parallel to one side of a triangle and it intersects the other two sides, then it divides the sides into segments of proportional length. So if these are parallel, basically what it's saying is if these are parallel, then we could say that this side, BD, and BE are proportional to this side, DA, and to this side, EC. So BD divided by DA should equal BE divided by EC. That's why it's called the side splitter, because this thing basically splits the sides into proportionality. And this works anytime that DE is parallel to AC. So the base of the triangles are parallel, then we know the sides are proportionate. That's basically it. And the converse of that, the reverse, says if they are proportionate, if the sides are proportionate, that means DE must be parallel to AC. And if these are not proportional, then these are not parallel. That's the idea. But if they are equal and they are proportional, then they must be parallel. So that's the converse. So let's go through some examples here. All right, it's telling us these bases are parallel, so we can say 12 over 14 equals 15 over x. And we know how to solve these by cross multiplying. 12x equals 15 times 14. 12x equals 210. X equals 17.5. Okay, so we take this side, 12, and divide it by this side. And then that should be equal to this side divided by this side. Pretty cool, it works every time. So let's take this guy. We know their bases are parallel, these two triangles, so we can say x divided by 18 equals 56 divided by 21. We could have gone the other way too. We could have put this on top and this on top and 56 on the bottom and x on the bottom. Doesn't matter as long as it's the same. So here we go. So 18 times 56 equals x times 21. So 21x equals 1008, x equals 48. Cool. All these will be the same. Let's get to a little bit trickier ones. 5, so we know these are parallel. So we know that 30 divided by x plus 7 equals 25 divided by 15. Cross multiply. We get 25 times x plus 7 equals 30 times 15. Distribute. 25x plus 175 equals 450. And let's solve for x. We get 25x equals 275. X equals 11. Let's let's see. 250. Yeah, it should be 11. 11. There we go. Now, this guy, a little bit different. We have 3x plus 11 divided by x plus 11. The only reason we can do this is because we know the bases are parallel. So the side splitter theorem says if these parallel lines split these two segments, we know this works. And then the next is going to be 21 equals 21 over, go back to purple, 6. Cross multiplying, 6 times 3x plus 1 equals 21 times x plus 1. And we distribute. 18x plus 6 equals 21x plus 21. 3x equals 27, x equals 9. Is that what it asks for? Does it ask for x? It does. These are a little bit different. These are saying, determine if MN is parallel to JL. So remember the converse. The converse says, if those sides are proportional, then they are parallel. So we have to show they are proportional. So 11 over 15.4 must be equal to 10 over 14. Is that the case? Yes. What about number 8? We get 15 over 4. Does that equal 18 over 5? No. And then so on. That's how you show those. If they're not equal, so not equal, are equal. You could just put them in your calculator and check, or you could find a common denominator and check that way. So if we did the common denominator, this would be multiplied by 5 over 5, by 4 over 4. That would be 30, 60, 75 20ths. And this would be, oh, not 75, sorry. 15, 30, 45, 60, 75 20ths. And this would be, what is, so 36, 72 20ths. Hence, they're not equal. Okay, let's keep going. So parallel lines and proportional parts. If AB, now we have 3 parallel lines. Parallel to CD, which is parallel to EF. So all these are parallel. Wow. Then we can show that AC over CE equals BD over DF. That's cool. So we can show that down here. Also, not too difficult. So now we have 3 parallel lines. They're all parallel to each other. That must mean 15 over 18 is going to equal 52 over x. And then we just solve for x. We get 45x equals 52 times 18. Whoops. So 45x equals 936. 45, oops, crap. X equals 20.8. There we go. Same thing for these. I'll just do the evens like before. So we know all 3 of these are parallel, which means x over 27 must equal whatever this is divided by 18. Since the whole thing's 32, 18 plus something's got to give me 32, so that must be 14. So we solve. 18x equals 14 times 17. 18x equals 378. X equals 21. Ooh, not 211. 21. Okay, keep going. 14. All 3 are parallel. Nice. So that means 24 divided by 18 equals 3x plus 1. Oops, wrong color. 3x plus 1 over 12. Cross multiply, we get 24 times 12 equaling 18 times 3x plus 1. 24 times 12. Oh man, I can't do that in my head. Let's see. 24 times 12. 24 times 12. 288. 288. Distribute. 18 times 3 is 36. 46. 54x plus 18. We get 54x equals 270. X equals what? And we divide both sides by 14. 270 divided by 14. 54 is going to be, I think, 5? Let's try it. 270 divided by 270 divided by 54. 5. Nice. And let's do 15 for good measure. All right, 15. So all three are parallel. Nice. So we get 12 divided by, let's change colors so we're not getting confused with the last problem. But first, I want to show that they're all parallel. It says it. So let's change to purple. We get 12 divided by x plus 3 equals 21 divided by 2x plus 2. Oy. Cross multiply, we get 12 times 2x plus 2 equals 21 times x plus 3. Get 24x plus 24 equals 21x plus 63. We get 3x equals 39, which means x equals 13. And we're done. Not too bad. All right, guys.